Hello there. Today we'll be working on trapping rainwater. This is our another problem with the 2 pointers. So let's see. In this particular problem, we're trying to find out how we can trap as much rainwater as possible. And to do this, we're going to be using 2 pointers. At every point in time, in this particular graph, what we're trying, in this array of numbers, what we're trying to do is make sure we can find out how much water we can trap at that one spot. Currently, we have left max, how high the wall is, and the right max at 0 and at 1. This means that we cannot trap any water. So we're going to move the lower point up so that we can find the place where we can start trapping some rainwater. Okay, so we moved left up. Left is now equal to right, and so that means we continue moving left up because this is equal. Once we get to 0, we see that we have a point which is lower than 1. So what we're gonna do is we're gonna take the left max and subtract the current height of left, so that we can see that we have 1 height of water. And so, because it's lower than right, we kind of move on and move forward. Now we're at 2. At 2, we are higher than left, and that means there's no water to be added to the water because we have a higher wall. And that also means that the right now needs to move down to be a 2. So now left max and right max is 2. And because they're at the highest points, left, right max minus right, basically the same point, is equal to 0. So there's no new height. So we moved we moved the left up because it's less than or equal to. And we see that there's 1. So 2 minus 1 is 1. So we now have 2 waters. We continue moving left. 2 minus 0 is 2, so we have 4 waters, and so on and so forth. Now we have 5 waters, and now we move to 3. At 3, we see that we're adding 0 water because the new max is set at 3, and the left max minus 3 is 0, and now we need to move the right. We add 1 more water because right max is now 2, 2 minus 1 is 1, and we have 6. We have 6 total waters, and we move to right, and 2 minus 2 is 0, and we move to right again, and we are at the same spot. So we're done with our operation here, and we have a total of 6 waters as seen here. So at every particular point, we're calculating how much water we can hold based on the left max and the right max, which we know of because the left max has to be less than the right max, so we know that's the maximum height of the wall. This way, we can find out how much water we can hold at that particular point by having these these values. All right, so let's get to the problem. So one thing you might ask is, before we get to the problem, is how did you come up with this solution? Like, how did you think of having a left max and a right max? Well, the idea here is that we need to find out that we need to calculate the amount of water we can hold at spots, and the parameters is that we need to look at the left side and the right side, and as far right as you need to go, or as far left as you need to go, the lower wall would be the cap. And so we will use that as our cap and move that pointer, and that way we can tell how much water we can hold. All right, let's get to it now. So first things first, let's set, if there is no height, there are no items, return 0. Let's set n to be the length of height, and left and right to be equal to 0 and minus 1. Then let's set the L max and right max to be equal to height of L and the height of R. Then a result to 0. While left is less than right, if the left max is less than or equal to the right max, it doesn't matter which way it is, we're going to have a L plus equals 1. And left max is equal now to the max of left max and the height of L. Then we set the result plus equals our left max minus our height of L, like we said earlier. Else, right minus equals 1, right max is equal to the max of right max and the height of right. And the result is plus equals right max minus height of right. So that does exactly as what we said earlier about how we will be finding our left max and right max and calculating the amount of water we can hold at that particular point. With that, I think we can return our results. Let's run the code. All right, looking good, and let's submit. Okay, not too bad. That's rainwater. That's trapping rainwater. Yeah, that was pretty fun. So unlike the previous problem where we were trapping rainwater containers, the largest max area, we're doing it at a much granular level. That's why we needed to look at every particular spot between the left max and the right max as we move in on the answer. Okay, what's the concept here in the 2 pointers now that we've come to the conclusion? Our last problem in these learning from the 2 pointers problems is that we see that there's always a list of numbers. There's always a list of numbers, or a palindrome, a list of, like a list, an array. And we're working to identify a variable that requires the left information on the left side and the right side. And this happens to be true for all the problems. So let's check out container, 3-sum, 2-sum, and the valid palindrome, including. So we checked out the left side and the right side. That's valuable information. 3-sum, valuable information. Looking at the left side and the right side of each particular target. 2-sum 2, same thing. Important information to get the 2-sum. Looking at the left side and the right side for information about whether we are getting closer to the total or not. Same with the valid palindrome. Looking at the left side and the right side for information whether it continues to be a valid palindrome or not. So we're generally working with lists and how these problems need information from the left side and the right side to create the solution. And usually these numbers, in some cases they're sorted, some cases they're not, but we're usually working with lists, and the information that is valuable is on the left and right side, and we'll close in on that information. So that's the concept that we're trying to learn here with this particular problem. It has a lot to do with arrays and strings. And I think that's the commonality between the pattern between all these problems, these two-pointer problems. Yeah, so I think we're going to be looking learning more about arrays in the sliding window problems as well, which is good fun as well. And we'll be learning more concepts. Hopefully we learned a lot about two-pointer systems, and we will be able to use them freely. Hopefully yeah, and yeah, maybe I haven't grasped the concept as well as I could. Maybe there's more to learn, and that's probably true. There's always more to learn, but this is the basic concept. And if you have more to share, please comment below. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.